Hashtag AGI is coming. Here's what humans will actually do next. Hashtag hook. 1.3 million Chinese kids fight for a spot at Tsinghua or Peking University every year. A professor from inside that fortress just said the quiet part out loud. ***. Getting into Tsinghua or Peking University, arguably the two hardest schools on Earth, is losing its meaning. Because right now, a large language model can teach you more, faster, than any professor at either school. The man saying this isn't some influencer. This is Professor Liu Jia, Chair Professor of Basic Science at Tsinghua, Chief Scientist at the Beijing Academy of AI, a full-time researcher in the cognitive neuroscience of intelligence. And he just published a book called General Artificial Intelligence. 10 Years of Thinking, Distilled. Today, I'm going to unpack the two questions inside it that matter most. 1. What is AGI actually? 2. In a world where AI is smarter than you at almost every task, what do humans still bring to the table? Then I'm going to add a layer he didn't put in the book. The 5-stage career evolution of every AI engineer over the past 40 years, and what it tells you about where your career is heading next. Buckle up. Let's go. Hashtag part 1. What AGI actually is. Everyone throws around AGI like it means something obvious. It doesn't. Liu Jia gives us the cleanest map I've seen. 2 axes. Environment, closed, fixed rules, or open, real world. And strategy, static, fixed playbook, or dynamic, adapts on the fly. That gives us 4 quadrants. Quadrant 1, closed environment static strategy. That's rule-based AI. It follows a script inside a defined box. Simple, doesn't scale. Quadrant 2, open environment static strategy. This was the classic symbolic AI dream of the 20th century. Simulate human intelligence out in the wild using rigid rules. Failed. The world is just too messy. Quadrant 3, closed environment, dynamic strategy. Now we're talking. This is AlphaGo, full self-driving. The rules are clear, but the state keeps evolving, and the AI adapts move by move. Quadrant 4, open environment, dynamic strategy. This is it. This is AGI, an AI that walks into a messy, unpredictable world and keeps retuning its strategy to survive and win, like a human. So AGI isn't defined by an IQ score or some benchmark. It's defined by one thing. Can it build dynamic, adaptive strategies in a world that won't sit still? Hashtag part 2, 3 roads to intelligence. How do you actually reach that 4th quadrant? 3 roads. Road 1, copy human behavior. That's reinforcement learning. Try something, get a reward or a slap. Adjust, try again. Same way you learn to ride a bike. Fall. Adjust. Ping, suddenly you can ride. Road 2, copy the brain's wiring. Neural networks. Connectionism. The bet here. Intelligence equals learning, and learning happens through networks of neurons strengthening their connections. Deep learning is this road industrialized. But road 2, for all its wins, still didn't get us to AGI. Something else did. ***. Road 3, copy human cognition itself. Natural language processing. Instead of copying behavior or wiring, you copy the knowledge, ideas, and cognitive structures baked into human language. ChatGPT is road 3 winning. Big time. It showed that if you drown a model in enough language, general-purpose intelligence just emerges. Hashtag part 3, the 5 skills humans still need. So, if AI is closing in on general intelligence, what should humans actually train? Liu Jia's answer, 5 skills. This is essentially a reimagined liberal arts curriculum for the AGI era. Skill 1, research. Not writing papers. The real skill is identifying the right problem. Good questions beat correct answers every time. Skill 2, statistics. We don't have too little information anymore. We're drowning in it, half of it fake, half of it AI-generated slop. Statistics is the skill of extracting real variables and real structure from noise. Skill 3, logic. First principles reasoning. Can you build a new understanding step by step from the ground up? Or do you just cite what someone else said? Skill 4, psychology. Understanding yourself and understanding others. Why are you working so hard? For what? Once your own compass is set, you stop being pushed around by other people's approval. Skill 5, rhetoric. Persuasion. Because nothing meaningful gets built alone. If you can't rally people to move together, your best ideas die on the whiteboard. Stack them up and you get a full growth arc. Research, statistics, logic, find truth. Psychology, find yourself. Rhetoric move the world. Liu Jia left one skill off the list and I want to add it back. Learning with a large model. That's exactly why he says getting into Tsinghua or Peking U is losing its meaning. With a good model sitting next to you, your learning speed smokes any classroom in the world. Now here's where I want to go beyond the book. I'm an AI researcher myself. I want to zoom out and show you something the book only hints at. The role of the human engineer has already shifted 5 times in AI history, and the direction of that shift tells you exactly what to do next. Hashtag part 4, the 5 stages of the AI engineer. If you watch nothing else in this video, watch this part. Stage 1, feature engineering, 1980 to 2011. The job, tell the model what to look at. ***. Old school machine learning had 2 parts. A feature extractor at the front, a classifier at the back. The classifier trained itself. The features, hand-designed by humans. The classic industry line, features matter more than algorithms. A whole decade of researchers doing feature engineering, handcrafting descriptors, tuning feature spaces. It was like teaching a kid to recognize an apple. Look at the color, look at the shape, look at the size. Humans were babysitting the model's eyeballs. But as vision tasks got harder, handcrafted features hit a wall. So people asked, can the model learn its own features? Enter end-to-end learning. Raw pixels in task result out. Everything in between is trainable. A lot of architectures competed. 1. Stage 2, neural networks, 2012 to 2020. The job, tune the beast. ***. Geoffrey Hinton, same guy who won the 2024 Nobel Prize in Physics, had 2 students, Krzyzewski and Sutskever. They trained an 8-layer neural net called AlexNet on 2 NVIDIA GTX 580 gaming cards and entered the ImageNet competition. Their error rate, 15.3%. Second place used classic feature engineering. AlexNet beat them by a full 10 percentage points. That wasn't winning. That was a demolition. AlexNet proved one thing. With enough data and compute, a neural network learns better features than any human ever could. Edge detectors at the bottom. Textures and shapes in the middle. Object parts at the top. Nobody designed those. They emerged. Feature engineering was dead. But now a new bottleneck. Neural nets have brutal hyperparameters. Architecture, depth, width, kernel size, learning rate, batch size, dropout, optimizer, millions of combinations. The engineer's new job? Tune the beast. The Chinese name for this work is beautiful, Landun, alchemy, because that's exactly what it felt like. Cook a batch, taste it, cook another. An engineer would spend 80% of their time on hyperparameter tuning, praying to find the right potion. Around 2016, Google introduced NAS neural architecture search to automate this. It grew into AutoML. Alchemy started getting automated. Then large models killed the whole industry. Stage 3, foundation models and prompt engineering, 2020 to 2023. The job, whisper to the model. ***. GPT-3. Everything changes. Foundation models come pre-trained. Massive. Ridiculously capable. Nobody needs to design the network or tune the hyperparameters anymore. The engine is built. Your job is to drive it. And driving turned out to be about one thing, what you tell it. Vague prompt garbage answer. Detailed, well-structured, well-contextualized prompt gold. So a whole new discipline was born. Prompt engineering. Craft clear instructions. Gather background info. Use chain of thought. Iterate. Early 2023, prompt engineer was a real job title. High salaries. Everywhere. And then it died. 2 reasons. 1, models got smarter. You no longer need to say act as an expert or think step by step. The model already does that. Fancy phrasing became obsolete because the model automated it. 2, prompt engineering couldn't solve the real problem, which was information flow. In 2020, models handled about 1K tokens. By 2024, 128K. Suddenly you didn't need to squeeze, you could shove entire documents in. But then people discovered context rot. Models get forgetful once you use even 10% of the window. More context is not equal to better. So the real question shifted from how do I say more with less to how do I make the model focus on the right thing inside a mountain of stuff. Enter context engineering. 3 moves. Recall. Pull the right info out of a huge pool. This is RAG. Compress, summarize, break into sub-questions. Organize, put the critical stuff in the model's focal zone. But even great context wasn't enough because models still have two fatal limits. 1. They can't act. They generate text. If you need them to send an email, query a database, control a device, dead end. 2. Knowledge cutoff. The moment training ends, their brain freezes. Ask about today's news, and they hallucinate confidently. The model is passive, static, trapped. Still with me? Good. This is where it gets fun. Asterisk asterisk. So evolution again. Stage 4. Agents. 2023 to 2025. The job, build the decision skeleton. Asterisk asterisk. Agents give models a pair of hands. External tools. APIs. The model can now query, act, observe, adjust. More importantly, an agent doesn't just spit out one answer. It runs loops. Reason decide what's needed, call a tool, observe, result, update, understanding, reason again. Real problem solving, not one-shot text. Agent engineering shows up in 2023. What does the engineer do now? Design the decision skeleton. How does the agent break a goal into subtasks? What tools can it call, when, how? What memory does it carry? Remember, forget, recall, discard? You stopped writing code. You started designing minds. But agents brought new problems. Search API times out. Now what? Is the agent actually progressing or spinning in circles? When it makes a mistake, does it repeat it forever? Giving an agent initiative without a control system? You didn't get autonomy. You got chaos. Stage 5. Harness engineering. 2026. Now. The job. Put reins on the horse. Asterisk asterisk. February 2026. HashiCorp co-founder Mitchell Hashimoto coins the term in a blog post. Harness engineering. A harness is what you strap onto a horse. A strong, fast horse without a harness runs in any direction. The harness directs the power. Same idea for agents. In agent mode, the whole loop of calling the LLM is automated, which means it's also error-prone, hallucination-prone, and free to go off the rails. Harness engineering is the control system. The core innovation. A clear, persistent, versioned rulebook. Injected into the model on every call. Goal definitions. Hard constraints. Roles. Permissions. Kept in a Git repo. When the agent screws up, you update the rulebook, and every future agent gets that lesson permanently. So a harness engineer's day looks like: define I/O specs, design tool call triggers, build feedback loops that autocorrect errors, and orchestrate multi-step execution so nothing drifts. Hashtag part 5. 2 patterns to take home. Zoom out on those 5 stages. 2 patterns jump out. Pattern 1. The innovation bottleneck loop. Every AI leap kills a category of work and creates a new bottleneck. Human engineers move up to solve the new bottleneck. A new engineering discipline is born. Just like cars killed the coach driver, but created auto mechanics, road engineers, gas stations, traffic control, and Uber. The job doesn't disappear. It migrates. Pattern 2. Human work migrates upward. Feature engineering, tell the model what to see. Hyperparameter era, optimize the model itself. Prompt era, give the model the right info. Agent era, design the decision skeleton. Harness era, govern the whole system. Each stage, you climb one level up the ladder of abstraction. From micro details to macro frameworks. From which pixels matter to which goals are legitimate. Here's the analogy that made it click for me. AI is your employee. You are a technical leader. If the employee is weak, you roll up your sleeves and do part of the job yourself. That's feature engineering. If the employee is strong, you stop touching details. You feed them better information. Prompt engineering, context engineering. You build them a better environment, agent engineering. And you set the guardrails and direction for how they operate inside the whole system, harness engineering. Being the leader takes completely different skills than being the operator. The higher you go, the more complex the system you manage, and the more judgment, taste, and decision-making it requires. Hashtag part 6. What this means for you. 2 patterns. 1 takeaway. Execution skills are being deflated. Strategic thinking is being inflated. Every layer AI eats, the value of doing that layer manually drops. But the layer above it, the layer where humans define goals and set direction, becomes exponentially more valuable. So if you're a computer science student today, obsessing over the newest framework or the sharpest coding trick, you're playing the wrong game. Those skills have shorter and shorter half-lives. AI will catch you at execution speed. Fast. The move is different. Drill down, but keep climbing up. Asterisk asterisk. Drill down means go deep on one thing. CUDA, chip design, ML framework internals. You still need real depth to be trusted. But recognize its half-life is shrinking. Climb up means keep raising your altitude. Coder, architect, strategist. From, how do I write this function, to what should this system even do? Depth isn't dead. But the center of gravity is moving upward. 3 ways to train this. 1. Do full-stack projects. Not because you have to be a full-stack developer, but because you need to feel the whole pipeline, data, model, integration, risk. Only then do you understand why the inelegant design is actually the safe one, and why a constraint that looks limiting is actually the thing that keeps the whole system alive. 2. Shift from how to why and what should we do. When AI can solve any well-defined problem faster than you, your job becomes defining the problem. Finding hidden assumptions. Asking, is this really the problem? Is the metric I'm optimizing actually the outcome I want? 3. Understand the philosophy behind the knowledge, not just the details. You don't need to memorize every PyTorch API. But you do need to understand the design philosophy behind frameworks. You don't need to handwrite a compiler. But you do need to understand compilation. Details rot. Principles don't. Hashtag part 7. The one thing AI can't do. Someone always asks me this. If AI keeps getting smarter, why won't it become the leader and reduce us to the employees? Fair question. Here's the answer. Every AI model, without exception, starts with one thing: a human-defined optimization goal. The whole training process is just a giant machine adjusting its parameters to hit that goal. But the goal itself? Someone has to define it. Someone has to say what counts as good, what counts as bad, what matters, what doesn't, what trade-offs are acceptable. Those look like technical decisions. They're not. They're human judgment, human taste, human values. That is the deepest moat we have in the intelligence age. AI can out-execute us on any well-defined objective. But defining what's worth optimizing for, that's still ours. AI answers questions. Humans decide which questions are worth asking. Asterisk asterisk. Which loops us right back to Liu Jia's 5 skills. Research, asking the right question. Statistics, cutting through noise. Logic, building understanding from first principles. Psychology, knowing yourself, resisting the crowd. Rhetoric, moving other people to move with you. Every single one of those is about setting direction, not executing tasks. Every single one is about the goal, not the process. That is not an accident. Hashtag closing. That's the book. Here's my closing question for you. 10 years from now, when AGI has taken over most of what we call work today, what will your one unbreakable, irreducible value be? Not what you can do. AI can do that too. What you can decide is worth doing. Drop your answer in the comments. I read every single one. Because 10 years from now, that answer, not your college, is what will define you. See you in the next video.